Now, is it clear?
Yes, sir. This is good,
Yes,
sir.
sir.
Okay, fine. So we were discussing ARM processor, or you can call it as ARM microcontroller. Okay. So what we were discussing can also call it as ARM microcontroller. Yeah. So ARM processor or ARM microcontroller. So whatever you refer it as, it's just a processor. Now, what is the ARM processor whose size is, Subramania?
32 bits.
Yeah, 32-bit microcontroller we called it as, and we discussed
With
so
RISC
many things.
architecture.
Yes. So we have discussed so many things. So we said what is the difference between microprocessor and microcontroller, correct? So we said what is the difference between microprocessor and microcontroller, and we said von Neumann architecture, von Neumann versus Harvard architecture,
Yes, sir.
correct?
Yes, sir.
Harvard architecture we discussed, and then we also discussed what you mean by CISC and RISC. Okay, we call them as processors. Either a processor may be CISC processor or RISC processor, or it may be having von Neumann architecture or Harvard architecture. It may be a microprocessor or a microcontroller. So all the differences we have seen. Now, when I say all these things are known to us, so it's a common factor. What is that? The simple common factor, we know that the CPU with additional devices, the CPU with additional devices, which we call it as external devices, okay, like RAM, ROM, hard disk, whatever you call it as, etc., forms forms your microprocessor. We just said like this, correct? Then we clearly said CPU, okay, CPU plus RAM plus ROM plus ADC plus DAC plus serial peripherals, right? Serial peripherals, serial peripherals plus timers, okay, plus dot dot dot. I can call it as few more. Together forms what?
Microcontroller, sir.
Yes, this is what very much important aspect which is required is a microcontroller. It means that the size of the RAM, the size of the ROM varies. The size of the RAM, size of the RAM varies when we cross check with respect to the microprocessor. RAM ROM sizes are less compared to compared to microprocessor. You can say microprocessor. So RAM ROM sizes are less compared to microprocessor. But as I mentioned clearly, the functionality, when it comes to the functionality, it is an embedded system. So microcontroller is an embedded system. It means it can handle one particular task. So this is so many aspects we have discussed. So now you know that uh, any microprocessor or microcontroller can be either von Neumann architecture or a Harvard architecture. Von Neumann architecture means data and core memory are lying in the same memory location, whereas Harvard architecture, in which data memory is different, core memory is different. So likewise we stated and we made the differences between von Neumann architecture and Harvard architecture, and in the similar way we said that a microprocessor or microcontroller can be either von Neumann architecture or Harvard architecture, or it might be RISC architecture or CISC architecture. So when I say RISC architecture, reduced instruction set computing, as the name itself indicates, the instruction set is reduced, wherein this complex instruction set, which is a CISC architecture. It means a microprocessor or microcontroller may be a RISC architecture or a CISC architecture. It means it may have RISC reduced instruction set, or it may have complex instruction set. If they are having that kind of instruction set, it means that that kind of architecture is there with them. Instead of saying not only the von Neumann or Harvard architecture, we can classify along with this with the RISC and CISC. With that, if we move on, any microcontroller or any microprocessor, if you list, everyone lies either von Neumann with RISC architecture, or Harvard with CISC architecture, or Harvard with RISC architecture, von Neumann with CISC architecture. Any combination is possible. Please understand. If I am lying on von Neumann architecture, it doesn't mean that I cannot be a CISC architecture. If I'm lying on Harvard architecture, it doesn't mean that I cannot be a RISC architecture or CISC architecture, nothing like that. So any combination is possible. That's what usually we say. All processors, it means the microprocessor falls under CISC architecture, wherein all microcontrollers falls under RISC architecture. As the name itself indicates, reduced instruction set is available with microcontroller and complex instruction set is available with microprocessor. That's the major difference. Now, just to move on, I thought of to start now. What is that? ARM programming with embedded C. Because anyhow, we need to start our lab simultaneously, maybe after 30th. So by the time, if you well versed with the tool, by programming certain aspects, along with learning the theory, not only going with the theory and understanding the instructions and how to realize the architecture, how to understand the processor, how the processor works, what are the things associated in steps, we will also start our journey with laboratory along with. It means we will start programming the ARM. Please understand, ARM programming with embedded C. When I say I wanted to program the ARM using the high level language called C. So if you know the C programming, it's very easy to realize the functionality of ARM processor. It means that how ARM works, how ARM can be programmed. So only thing is the C program must be written. As I said, simple way, C program, as the name itself indicates, program is nothing but the collection of instructions written sequentially to achieve a particular task. Now my interest is, I need to write the instruction. Which instruction? I need to use the instruction set available with the ARM processor. Okay, so that's what I'll simply start with few things. Quickly just understand what is that, how I am going to start with. I'll just say that first, what is instruction in ARM 7? I'll start with quickly ARM 7, and in the next class maybe I'll come up with the programs and we will start working with the programs with the Keel software, nothing to worry. So that will also help your lab as well as the theoretical aspects of your subject. Okay, now what is that I'm trying to talk? ARM 7, when I say it's a microcontroller which we are talking about, 32-bit RISC architecture microcontroller, as Subramania said, it's a very simple idea. Now you can observe this, what I wanted to know. If I wanted to know what is instruction and instruction set, okay, available in ARM 7. So when I say any microcontroller, it must and should have the collection of instructions. If it has collection of instructions, it is called instruction set. Then I should know what is instruction. Along with that, I need to know what is RISC and CISC architecture. I need to know this already I know. Just what do you mean by CISC and RISC instructions? I'll say instruction, ARM 7 I started. I'll say instruction and instruction set, and I'll say RISC and CISC instruction. RISC and CISC instruction. And after that, I'll say ARM instruction set. Please see, I am writing the words with respect to instruction only. I started with my journey with the ARM 7 processor, which is a 32-bit microcontroller. When I say microcontroller, it must and should be associated with instructions. What is an instruction? What is instruction set? Then I should know what is the RISC and CISC instruction, which falls under this. We'll see. Then what are the different types of ARM instruction set available? We should start with that. Then when I understand ARM instruction set, I need to know ARM addressing modes. ARM addressing modes. ARM addressing modes. What do you mean by addressing modes? So instruction set and addressing modes are very important. Instruction set and addressing modes are very important. So now then I'll say ARM instruction classification. Then in detail we should go. ARM instruction classification, you can say ARM instruction classification. Okay. First, what is ARM instruction set is available, then ARM instruction classification, each one we need to go thoroughly. For example, I have so many. To start with, I will say data processing instruction. Data processing instruction. So like this, we should start our journey. So before going to instruction set and all, we need to go to the core. What is that core? So I need to know what the ARM controller, okay, what are the basics associated, and how the ARM controller can be used for various applications that we already seen. What are the different examples and how the different architectures looks like, what are the differences between microprocessor and microcontroller, von Neumann architecture and Harvard architecture, RISC architecture and CISC architecture, and what is the working principle behind microcontroller. If somebody asks, it is same as the microprocessor working principle. We have seen the working principle of microprocessor. How really microprocessor works? It works with the concept of fetch, decode, execution cycle. How it is? I said that there is a CPU, there is a memory associated. Whatever the program you will write, the program is collection of instructions. All the instructions will be first moved to the memory, which is RAM. Then what will happen? Now the processor responsibility to take all the steps. What are those steps? It means take instruction by instruction. First, there are 3 important registers with the microprocessor. Similarly, all the microcontroller will have important registers. Now you recall how the working principle. CPU has program counter. What is that? PC. It has instruction register. It has ALU, we said. It means that fetch. When you say fetch, program counter is pointing to the first memory location, first address of the memory location. It fetches the instruction from first memory location and it decodes at the instruction register. Instruction decoder, you can call it as instruction register or instruction decoder. Once the instruction is decoded, it should be executed and execution operation will be performed by various blocks. Various blocks means if the instruction is associated with ALU, ALU performs the operation. It means addition operation or logical operations can be performed by ALU, or some memory related operation, memory will come into picture. Register related operation, registers will come into picture. If it is a multiplier related operations, MAC will come into picture, that is multiplier and accumulator block. It means execution happens by those particular blocks. Finally, the result will again be stored in a register. Again, one more important register which we called it as accumulator. So what I'm trying to say here is every microprocessor or microcontroller does the same operation. How they do the operation? They fetch the instruction from the memory one by one by using the register status. One register used to store the address of the memory location from where the instruction has fit. Another register is used for decoding purpose, and the next register is used for storage purpose. After the execution, the storage is required. That's what storage purpose. So registers in the microprocessor or microcontroller plays an important role unless the execution of a particular instruction. So that is what the ARM7 to start with. ARM7 is a 32-bit microcontroller. It is a 32-bit RISC, okay, controller, okay, RISC controller. So what it has instruction. What is the instruction? Instruction is nothing but the command given to the processor. Where this command will be? When I give a first command, it will go and store in the memory location. Then the processor has to fetch that instruction, and that instruction should be decoded by the decoding register. Then once the decoding operation is done, execution has to be done. After execution by any of the block which is associated with the instruction, the result will be stored again in a register. From the register, it may go to some other register for the storage, or it may go to a monitor, it may go to a memory. It depends on. So just instructions plays an important role to achieve a task. That's what everything should be an instruction. Collection of instruction written sequentially to achieve a task is called as a program. So now microcontroller can handle two ways, either assembly language programming or high level language programming. C programming is a high level language programming. There is a microcontroller programming which we can refer it as an assembly language programming, which we are not very much worried, which we will study when we start with the ARM core. That we will come to that point. Assembly language programming, it is called as ALP. How to write an assembly language program and how to execute, where to execute, that we will see. So it has two programming stuffs. You can say assembly language programming, and then there is high level language programming. First, we will start with high level language programming, which is useful for our lab purpose also. How? By writing the instructions. So you know what is the instruction. It means every microprocessor or microcontroller is associated with an instruction, and collection of those instructions is called as instruction set. What is an instruction? An instruction is a command given to the processor to understand a particular task. For example, add, add is an instruction. The command given to the processor understands it as an addition operation. This addition operation will be done by a particular unit in the microcontroller, which is called as ALU unit, which understands this instruction as an addition operation. It does the addition over the contents of the registers, It means instruction is associated with register or memory location. It's a general understanding. So let us say, for example, add R1 comma R2. If I say like this, you might not understand what I am saying. You can just feel like this. Add is an operation. R1 comma R2 are the two registers. As we know, registers are very important, which are temporary memory locations, you can say. So use those temporary memory locations for the purpose of programming. That's it. It's a very easy way to say an instruction add R1 comma R2 says that add the contents of R2 with register R1 and the result is stored in R1. That's the meaning of instruction. This meaning has been already fed as an instruction. This meaning has already been fed as an instruction in the ARM microcontroller instruction set. Instruction set means collection of so many instructions doing different tasks. Combination of them will help us to achieve an important particular task. So what you call it as applications. You can achieve any application by writing set of instructions together in a sequential fashion to achieve the particular task related to that application. That is the instruction set. So with that, we know that there is a CISC architecture and RISC architecture. It means basically we are talking about CISC instruction set and RISC instruction set. So instruction set, I can say either CISC instruction set and RISC instruction set. ARM7 is a RISC, R-I-S-C, is a RISC instruction set. If you observe, RISC refers to reduced instruction set computing, whereas CISC refers to complex instruction set computing. Now you understand, I'll say RISC includes few instructions. So ARM 32-bit controller is a RISC instruction set, is a RISC architecture which includes few instructions, whereas CISC instruction, it has many instructions. 100 to 200. Now you see, if ARM instruction set is a RISC, it has few addressing modes, whereas CISC has many addressing modes. Now another term came. What is that? Addressing mode. What do you mean by addressing mode? I understood what is instruction and what is instruction set. What is addressing mode? Addressing mode is the various ways of specifying the operand is called as addressing mode. The various ways of specifying the operand is called as addressing mode. Now you understand what is the meaning of addressing mode. RISC architecture has few addressing modes. CISC architecture has large addressing modes. Addressing mode means the various ways of specifying the operand in an instruction, you can say. For example, if I write add R1 comma R2, add R1 comma R2, Here add is an instruction, R1 comma R2 is the register. Now you understand, if an instruction is associated with the data, because R1 and R2 is carrying data. If for example, I will say move, move 2000. 2000 is a memory location. But 2000 is a memory location has a data in it. So anything which is associated with the data is called as operand. For example, add R1 comma R2, then I'll say either R1 or R2 are called as operands. Add is called as opcode. It means an instruction has two parts, opcode and operand. Opcode and operand. Add R1 comma R2. Add is an opcode. R1 comma R2 is operand. You can say like this, just for clarification. Move 2000. It means that move 2000, move A comma 2000, let's say, or move R1 comma 2000. So whatever is there in the 2000 memory location is moved to register R1. So move is an opcode, you can say, whereas R1 or 2000, whatever data it has, it is called operand. Move is opcode, whereas register R1 and 2000 is called as operand. So anything associated with the data is called as operand. So RISC has very less addressing modes. CISC has variety of addressing modes because large number of instruction set means variety of addressing modes. Addressing modes, there are various addressing modes. For example, register addressing mode. When I say register addressing mode, operand is a register. That's it. As I said an example, add R1 comma R2. It's a register addressing mode. Direct register addressing mode, indirect register addressing mode. I will say add R1 comma 10. Directly I am moving 10 to the register R1. I mean adding. Or let's say move R1 comma 10. 10 is directly moved to R1. 10 is a number here. I will write it as hash 10 to show it as a number. Hash 10 means a hexadecimal number 10 is moved to the register R1. If I write the instruction like this, move is the opcode. Okay, R1 will have hash 10 now. Hash 10 is moved to R1. It's a direct register addressing mode. An instruction of type direct addressing mode, direct register addressing mode. Move R1 comma R2. It means register indirect. Register to register. So that's what I'll say, register indirect addressing modes. Let's say move MVI. MVI says move immediately. Move immediately. A comma 15. So 1 5 I am moving it to accumulator A. MVI indicates immediately. If any instruction is associated with the letter I, it is an immediately. That's what addressing mode is called as immediate addressing mode. So not only the instruction, so many instructions in the instruction set, every instruction is associated with the particular type of addressing mode. Please remember. How many addressing modes are there? What are different types of addressing modes are there? We'll see. Okay, so we just say now ARM 32-bit is a RISC controller. RISC has very low addressing modes because low instruction set is there, whereas CISC is having very high instruction set, means large number of instructions are there, hence it needs large addressing modes. ARM instruction set, that's what is a specific. Now I need to specify ARM instruction set. What is the difference I am studied above? I just said generally what is instruction and what is instruction set. ARM instruction set is basically classified into two types. One is ARM instruction set itself, another is thumb instruction set. So ARM instruction set is basically divided into two sets. One is ARM instruction set, another is ARM thumb instruction set or thumb instruction set. One is 32-bit instruction set, another is 16-bit instruction set, which is an additional instruction set to make the programming easier or to achieve some other tasks. Then thumb instructions plays a role. So there are addressing modes. ARM has specific set of addressing modes. As I said, any microcontroller or microprocessor has to have addressing modes. The number of addressing modes are fixed. the number of addressing modes are fixed. But here also in ARM 32-bit microcontroller, the number of addressing modes are fixed. What are the different addressing modes? I will just name a few. Let's say register direct addressing mode, direct addressing mode, immediate addressing mode, register indirect addressing mode, register indirect with offset addressing mode, register indirect pre-incrementing mode, register indirect post-increment addressing mode, register indirect, register indexed addressing mode. So likewise, I will list all and we will let know how these addressing mode helps us to write a program in a simpler fashion. So that is what. So ARM instruction classification. This is the path we will go ahead one by one, and we will start with the instruction classification with the data processing instruction as the first instruction set. There are various instruction sets classified independently, and each one has to be studied thoroughly. That we will see. Before going to this, as I said, I need to go with ARM 7 32-bit RISC controller with the core architecture. So it means we will start with core architecture. It means I will discuss on what is the block diagram associated with ARM, how it works. So if I understand ARM core, then the rest of the things will be your syllabus point of view that we will discuss in the next class. Okay. So today I'll just say now we will start with instead of going with ARM core instruction set, okay, addressing modes and instruction classification thoroughly one by one. That is your syllabus. Before going, I will directly move on to ARM programming. ARM programming we will start, and that too IO ports programming. IO programming we call it as. We'll utilize the IO ports and how to do the programming. ARM programming with embedded C. Embedded C should be our target. Okay, so we'll start with this, and let us discuss on this. Okay, so this is the first class. We'll start with the ARM programming with embedded C, and which is nothing but the fourth unit of your syllabus. We'll try to cover few things from fourth unit and then come back to the first unit, so that simultaneously you can work with the lab along with the theory. That is what my intention. So what is the flow I'll go with? I'll go with ARM 7 32-bit RISC microcontroller. Then thoroughly we'll study ARM core, how it works with the block diagram representation, which is important for the exam point of view. Then instruction and instruction set, which is available. RISC and CISC differentiation, you know. Then thoroughly ARM instruction set classification and how each one goes, we should study. Then ARM addressing modes, how each one goes, what is the understanding with respect to program, we will study. Then thoroughly instruction set, we said now we will classify those instruction set based on the operation what they do, like data processing operations, branch operations, rotate operations. Likewise, based on that we will classify and thoroughly will study all the instructions how they work. After that it becomes very easy for you to write any program to realize any task in your hand. So to start with, what we will do, we will start with ARM programming with embedded C using IO port or IO programming. Okay, input output programming. So that we will start. So before that, let me ask, when is the next class? When is the next class, Subramania?
So tomorrow at 11 a.m.
No, not mine. Now. What is the next?
No,
At what time next class starts?
it's 11. So at
10?
11 o'clock.
No, miss. 9 to 9:45.
10 o'clock class is cancelled.
It's cancelled.
Yes,
Okay.
sir.
What about 10:45? One more class is there, right?
Yes, sir. At 11 o'clock it is.
Okay then. I got some free time to speak because we wasted half an hour in dealing with this, right?
Yes,
Okay.
sir.
Yeah, Subramania, you were there, right?
Yes, sir. Yes, sir.
Okay. Now,
Sir, your screen again stopped showing in laptop.
oh, It's not moving, huh? Now
I
you
don't
see?
know about a mobile. PC, it's not coming up.
Oh. Now what is the heading visible now?
No, sir. Like it's completely a blank screen.
Others, Gaganashri, my screen is visible, right?
Yes, sir, it is visible.
Okay, if I write something, let's say what I'm writing, you tell me.
ALU.
Yes. Okay, it's visible. Subramania, please cross check. Yeah. Now I'll give some basics. Okay. Now I'll give some basics. You try to understand accordingly. See here. Uh, what I'm doing now. Can you tell me what when I'm doing any ARM programming with embedded C? Okay. What are the most important blocks we have? What are the most important blocks we have? We have we have ALU, okay, ALU, register, and timing and control. Can you see this? Subramania, is it visible now?
No, sir. I'm looking at my bank. Just
Oh,
reconnect again.
oh, okay, okay. Then who else? Asma Banu,
Yes, sir.
my screen is visible.
Yes, sir.
Ayush,
Yes, sir. It's visible.
yeah. So now, if I say any of the microcontroller, it has to have block. You write these things in a blocks. What is this box? A microcontroller, a microprocessor has to have minimum blocks like this. What is ALU? It is nothing but arithmetic, arithmetic and logical unit. Logical unit. It means what it does? It performs arithmetic and logical operations. Logical operations. Okay. For example, can you list the example? Let's say add. Okay. Add or XOR. If you write like this, okay, XOR, or you write XOR like this. So add or XOR or the operations which are carried by this means an arithmetic logic unit is the most important part of any microprocessor or microcontroller. Does arithmetic operations like addition, okay, ORing, XORing operations. If these operations are handled by a particular unit, such unit is called as arithmetic logic unit. Please remember this arithmetic logic unit is made up of digital circuit. You know what is half adder, full adder, okay, AND gate, OR gate, XOR gate. Everything together forms an ALU, you can say. That's a very simple idea. So ALU is the basic part of our microprocessor. Then comes register. Microprocessor or microcontroller, anything you take, registers are very important. There may be lots of register. So let's say there are different types of registers, GPRs and SPRs. So what do you mean by this? If I say general purpose registers, general purpose registers and special purpose registers. Okay, so general purpose registers and special purpose registers. Now you observe what I just wanted to say. ALU is one part of the microprocessor or microcontroller. Second part I said registers. Why I said this? Every microcontroller and microprocessor should have certain registers. I can classify them as general purpose registers and special purpose registers. Okay, what is that they do? They're used for temporary storage of data and intermediate results. What for they used? They used for temporary storage of data. Temporary storage of data is the only thing? No, not only that. Temporary storage of data, and they can also store intermediate results storage. Intermediate result storage. See, the general purpose registers and special purpose registers do some operation. Usually general purpose register means they are general. They usually use for some temporary storage of data or intermediate result storage when the execution happens. It means result storage when the processor is making or doing some execution of the program, doing execution of program. That's it. So processor is doing execution of program. What is the meaning? It is taking instruction by instruction, decoding it and executing it. While fetching, decoding and executing, some result is coming out. Those results should be stored somewhere. Where they are stored? In the registers, general purpose register or special purpose register. But as the name itself indicates, general purpose registers are basically for temporary storage and intermediate storage of the results, whereas special purpose registers are used for some special applications, special purpose, only for special purpose only. Let us see what are those registers which does some special operations. That is very important. So if somebody asks, what is the specialty of microcontroller? What is the specialty of ARM controller? What is the specialty of PIC microcontroller? Then you should say specifically that these microcontrollers have these many general purpose registers, these many special function registers. Register is a storage device. Register means 8-bit device, 8 flip-flops together forms one register called as 8-bit register. It stores 8-bit. A register can be 16-bit register. It stores 16 bits. A register can be 32-bit register. It stores 32 bits. This you know. So register is a storage device. What it stores? Temporary storage of data or intermediate results when the processor does the execution of the program. Not only that, the special function registers are there. Special purpose registers are there. They are used for doing the special purpose operations or special operations you can call. So ALU is not only the important block, registers in that microcontroller is also an important block. Another important block is timing and control. Without that, nothing can happen. As I mentioned, clock is the heart of the microcontroller. That's what is the timing and control unit will do? It provides, you just say it provides necessary time control. What they provide, you see, what is the timing and control unit will do? It provides necessary time I'll say and necessary time and control signals. So timing signal, control signal. Timing signal is nothing but clock signal. Control signal is nothing but a signal which says yes or no. Whether operation should be performed or not is decided by control signal. So timing and control signal are given by this. And then what is that it is called as? What the timing and control unit will do? It controls the flow of data. Major important aspect is why the timing and control signal. It not only provides the timing signal and control signal, what it does, it controls the flow of data between microcontroller and peripherals. You can say it controls the flow of data between microcontroller and peripherals, you can say. That's how all the processors will have definitely this, correct? Will have definitely this. So please remember, this is where we are just going ahead with. This is what we discussed, and we said now ALU, registers and timing and control unit. So if somebody asks, if these three are there, things are almost done with any of the processor. any of the processor. Now, for example, let us start with ARM programming. ARM programming. ARM programming with what? ARM programming with embedded C. If I say, then I need to write a C code by utilizing the instruction set available in the ARM. But which ARM programming you are doing? I wanted to use the IO ports of the ARM processor and do certain programming. Now, to do the IO programming, I need to know about LPC. LPC 2148 is a 32-bit ARM 7 microcontroller. LPC 218 is a 32-bit ARM 7 microcontroller. So what it has? You just tell me what the 32-bit microcontroller, when I list, what I need to write now. So when I say I wanted to start the IO programming is one type of programming or one part of the programming in the ARM. How I should start with? So I need to know what is ARM controller, which is nothing but LPC 2148. 2148 is what it is. If somebody asks, you should say it is a 32-bit, okay, 32-bit RISC, or you just say first 32-bit microcontroller, nothing to worry, 32-bit microcontroller or 32-bit ARM controller, you can say, and which is having the RISC architecture, you can say, which is having the RISC architecture. So it means that there are few instruction set. RISC architecture, it has two architecture. Now, if somebody say any type of microprocessor or microcontroller, what is the general thing I need to write? Whether it is a 32-bit or 16-bit, which we call it as specifications. Can you write the specifications of LPC 2148? If somebody says, it means that I need to write the details of LPC 2148 is one of the 32-bit microcontroller, or you can call it as ARM controller. You can say ARM 7 controller. Okay. So can you list the specifications of this LPC 2148? Somebody asks. You list out whatever you know about ARM 7 controller. That itself is an LPC 2148 controller. But there are few specific things. When you say ARM 7 controller, in general you will say what? In general you will say the ARM 7 controller is a 32-bit microcontroller. It is a RISC architecture. Okay, it has RAM this much, ROM this much. When I say a random access memory, this is the range it has. What is the range it has? You will say what is that, 4 KB to 40 KB, something like that, or 3 KB to 40 KB, or 2 kilobytes to 40 kilobytes. And when we say ROM size, 32 kilobytes to 256 kilobytes ROM size, you will say. And what else it has? It has ADCs, it has DSCs, it has timers, it has serial interfaces. Like this, you will say the specifications of the ARM 7 controller. Now, if I say a particular family of ARM 7 controller, which is LPC 2148, if I take, so that's what the people will write like this: LPC 214X. It means X is the family. 2140 is different than 2148. Slight variations will be there. Different versions of the microcontroller, you can say. So LPC 2148 is a 32-bit microcontroller. It's an ARM controller. What is its specification? If somebody says, you need to write all the things. What is that? First is, it is 32-bit. Okay, it is a 32-bit ARM 7. It is a 32-bit ARM 7 microcontroller. You can say microcontroller. Like this, the specifications you are going to write. Microcontroller. It is the first specification. Second specification of this is what? It has RAM of 40 KB kilobytes, 40 KB of RAM. Specific. That's what I'm writing specification. What is the specification of LPC2148? What is the specification of LPC2148? Okay, RAM size. It has ROM. What is the ROM capacity? ROM capacity random, which is of 256 kb. Okay, if I write like this, 256 kb kilobytes. So like this I'm writing. So specification. Okay, now how many it has? 10-bit ADCs. Okay, 10-bit DAC. Such kind are there, two. Okay, two in numbers. Okay, two ADCs. Okay, and ADC means analog to digital converter. DAC means digital to analog converter. 10-bit means how many inputs it take, how many outputs it will give. One output for DAC, 6 output for ADC. Let us cross check all those pin configurations in detail. 10-bit ADC, it has timer, it has one timer, it has one timer, you can say one timer. Okay, what is this timer? We will see. What you mean by timer, what you mean by counter, the differences we need to understand as and when we go. One timer, it has one watchdog timer. So it means I'm writing the specifications. That's it. What that LPC2148 has. Okay, so now it has one watch like this, one watchdog timer. It has two what is that? I2C. It has two I2C. It means serial interfaces. It has two inter-integrated circuit, I2C or I square C, you can call it as. I square means inter-integrated circuit. So which is nothing but the serial communication interface. You can say serial communication interface. I have such two interfaces. I have two SPIs, serial peripheral interface. Likewise, one USB, I have one USB interface. Okay, so likewise, what is the meaning if somebody asks? Whenever I say a microcontroller is having CPU along with RAM, ROM, serial interface, timer, so many you can list whichever comes across the architecture. Okay, whichever comes across the architecture. This is some basic representation of LPC2148. Now I will say LPC2148 has 64 pins. Please understand, this is an important point. Now if I take LPC2148 as a microcontroller, as a square box, around the square box, how many pins are there? Total 64 pins are there. So it is a 64 pin package IC, you can call it as a big IC with 64 pins, out of which 48 pins are for IO ports, IO pins, you can call it as. 48 pins are IO pins. 48 pins are IO pins, in which I have 3 pins reserved. 3 pins reserved. So it means how many IO pins are practically available for us? Subramania, how many pins are available?
Sir, 45. Only 45, right, sir?
Yes, only 45 pins are available for usage. So what is the meaning? Now I came to a concept of usage of IO ports. So I have 48 IO pins. When I say IO, input and output pins, it means all 48 pins are input pins, all 48 pins are output pins, or few pins are input pins or few pins are output pins, nothing like that. So we are going to say them as GPIOs, general purpose GPIOs. Okay, general purpose input output pins. You can call them as general purpose input output pins. General purpose input output pins. Just understand this: general purpose input output pins. It means they are doing some general purpose inputting, general purpose outputting. It means either I want to make them as inputs or I want to make them as outputs. When I say I want to make them as input, means they are ready to receive the input. Then only I'll call it as input pins. When I call the pins as input pins, they are ready to receive the input. When I say I'll call them as output pins, they are ready to give the output. Now these input pins, either they can receive the input digital data or analog data. Then I'll call them as digital inputs, digital outputs, analog inputs, analog outputs. So it means I will reserve some pins for inputting digital data. Then I'll call it as digital inputs. If I reserve some of the pins for inputting analog data, I'll call them as analog input pins. If I reserve certain pins for outputting the digital data, I will call them as output digital pins. If I am going to reserve some of the pins for analog outputting purpose, then analog output pins. So that's what GPIOs can be general input or output pins. Then how to know that this GPIOs can be utilized accordingly? So for that purpose, we have IO programming. To do IO programming, one interesting part is that how a microprocessor or microcontroller works. If somebody asks, as you said, it makes use of ALU, it makes use of register, it makes use of timing and control unit, it makes use of memory. All four together in a processor, the processor makes use of all these four and does the execution. Now here also, if I wanted to program or if I wanted to execute the things with respect to IO ports, then I need to utilize the registers associated here. What are those registers which are utilized for programming IO ports? Please remember, how many IO ports are there, how many IO registers are there, that we will see. So I will just list the registers now. I have registers which I call it as IO pin register, IO DIR, IO set, and I have pin cell register, pin cell. So it means I have, these are the registers. What is this? 32-bit registers. 32-bit register. So I'll make use of, if you remember in the above block, I just explained ALU, register and timing and control unit. Registers are very important. Everywhere when you are programming something, registers plays an important role. What for they are used for? For temporary storage of results, or sometimes uh, uh, for passing the results to somebody else, or for configuration purpose, to do the configuration. So IO pin, input output pin, IO direction, IO set, then I will have IO clear are the registers. All are 32-bit registers. You can see all are 32-bit registers. You can call them as 32-bit registers. Now when you see this, uh, IODIR, what is the functionality associated? So it means these registers are used for certain things, which is called as configuring the IO ports. These registers are used to configure the IO port. So how many registers are there? Pin cell, IO pin, IODIR, IO set, IO clear are the 32-bit registers. If I put some value in these registers, then the processor will understand that this is what the task I need to do. Okay. For example, if IODIR means direction of IO ports is defined by IODIR register. If IODIR register is having 32-bit register, it's a 32-bit register, it stores 32 bits. If all the bits of this register are set to 0, it means all the pins this register is pointing to, that I will show. All the pins this register is pointing to are made as in input pins, because I'm setting low. If all 32 bits are made high, then I'm declaring that all the IO pins to which this register is pointing to, this register is pointing to which pins. If all the 32 bits are made high, then those pins are made as output pins. So the value present in them plays an important role. That's what these registers can be called as configuration registers. Registers not only used for storage, they can also be used for configuration. Okay, configuring the IO ports can be done with these registers. Pin cell, as the name itself indicates, pin select, IO input output pin, input output direction flag setting either low or high, IO set. It means making, once I declare those pins as output pins, what is available at those output pins, whether high data is available or low data is available. If I make it as IO set, then the high is available on those pins. If I make them IO clear, it means if I put zeros onto it, 0 is available on those ports. So configuration is done through these registers. That's what these registers are called as configuration registers. We will see how to make use of these configuration register to start our IO programming in the next class. I'll just stop here. We will discuss each one of this and how to put the value, how to see the result. Simultaneously, we'll observe with execution. I mean, we'll execute a program, we'll see how this happens. Because already the architecture of LPC 2148 is readily available, which we people are using. Only thing is we need to make use of these register configuration register and ensure the particular operation with respect to IO ports. IO ports are very much essential part of your microcontroller, which does so many operations. What are those operations with the external world? We will see one by configuring these registers one by one in the next class. I'll stop here and we'll continue in the next class. Okay.